welcome. Good morning, everyone. It's a real pleasure for me to welcome Mr. Eloy Rodriguez, who is one of the leading experts in Europe on open access, and he's been a member of COARA and many other institutions. Has been working on the field for more than 20 years already, and has been involved in all the major initiatives at the European level. I would like to thank especially Eloy for making time in his very busy agenda and to be with us for giving this talk and the first of two in these training sessions as a part of the Open Science and Open Data initiative for Stars EU University. Just a quick reminder, we are going to record the sessions, and the session will be also broadcasted live. So please, all of you who are in this chat room, just mute your microphones. And if you have any questions, comments, I think Eloy will be very happy to answer at the end of the talk here in the room. So thank you again, Eloy, for being with us, and the floor is yours, and we are very happy to listen to your talk. Thank you.
Okay, thank you very much, Ernesto and Jose. Thanks for the invitation to make this workshop for the Stars EU Alliance. Is a real pleasure. I was telling that I'm from Eloy Rodrigues from Universidade do Minho, Portugal. We have strong relations, at least with one of the members of your alliance, the Polytechnical Institute of Bragança. But I also had some previous relation with La Laguna University, so it's really a pleasure to be here with you today. I think you are seeing my screen. It has advanced to the agenda. Just confirming because I switched screens. It's are you seeing the agenda slide? Can you?
Perfect. Yeah.
Okay. So this workshop we will have two sessions: the session today and the session next week. So for the section today, I will do and we'll spend most of the time today on a kind of an introduction to open science, to discuss the concept, the definitions, the components, and the different dimensions of open science, and then zoom into to open access to publications, especially the more fundamental and practical questions of how to publish in open access currently. So, what is open access? Why open access is important, and how should we proceed? And then I'll talk a little bit about the colors and flavors of open access. For the second session next week, I will dive a little bit more on the current trends and some new models for scholarly publication and communication that are related also with open access. So talking about preprints, the publish, review, curate model, open peer review, and other things. And then also we'll spend a significant part of our time next week talking about research assessment and the reform of research assessment and related to the agreement on reforming research assessment and COARA. So I would like you to just to have an idea to very quickly, we just spend 2 minutes or 1 or 2 minutes on this. If you could go to menti.com and insert this code, or if you have a cell phone, you just need to use this QR code, and because I would like to know who you are. Let me see here. So I would like to know what kind of audience I'm having here today. I just have one question. One answer, sorry. Can you can put again my slide if it helps. So menti.com, then enter the code 45424216, or use the QR code to go directly to the still just one person. Are you having problems with the okay, two? Just wait a little bit, 1 minute more. Let me see how many people we have here. We have 10 people. I don't know if there are other people because this has been streamed. I don't know if there are other people online. Let me wait at least that we get 6 or 7 answers. Okay, 5. Just see if we can. 1 or 2 more answers, please. Menti.com 45424216. So, okay. We have we have 6 answers. Okay, I will move. I'll move it. Anyway, we have mostly teaching. Sorry, here. We have mostly teaching. Teachers and professors, and just apparently just 1 researcher and 1 support staff. So, as I said, so let's talk a little bit about the concept, the definitions, and the components and the dimensions of open science, and also trying to reply to the what, why, and how of open science. So, starting for the first part about the what for open science. By the way, we'll have I will try to reserve at least 10 to 15 minutes at the end for questions and debate, but please feel completely free to interrupt me and ask any question. As I'll be presenting, I will not. So if you put something on the chat, I will not probably see it, but you can just open your microphone and put your question. Okay. So. Starting for the first question, open science, what is open science? There are several definitions of open science. This is one that I particularly like because also it was coined by a project that I was the project coordinator and fostered open science 8 or 9 years ago. And our short definition is that open science is the practice of science in a way that others can collaborate and contribute. And that's exactly an important part of open science, that the openness is not an end in itself. It's really means to promote advancement and contribution, and where the research data, the lab notes, and other research processes are freely available and can be reusable by other people. But more recently, there is the UNESCO in 2022 as 2021, sorry, has established a recommendation on open science, and this is probably now the most known document about open science because of the breadth and the scope of UNESCO. And the UNESCO definition has defined open science as an inclusive construct that combines various movements and practices. And this is a first aspect that I want to highlight. So and I will come back to it in a minute. So open science is really a complex concept that really combines or encompasses different movements and practices, and then the objective of open science is to make scientific knowledge openly available, accessible, and reusable for everyone, both in the academia and outside the academia. Again, the point about increasing scientific collaboration that was already also mentioned in the Foster Open Science definition, and also another important aspect of this UNESCO definition is that the openness is not only on the process of scientific knowledge creation, but is also on knowledge creation, evaluation, and communication, and again to all society and not only to the scientific community. So the scientific community is the main actor and the main beneficiary of open science, but is not the only one. So, and we need to take that into account. And then it ends. The definition ends identifying some key pillars of open science: open scientific knowledge, open science infrastructure, science communication, open engagement of societal actors, and open dialogue with other knowledge systems. These next slides are in a way they summarize and they graphically represent this. So open science, what does open science, what is the contribution and the value of open science? So increasing scientific collaboration and sharing of information for benefiting science and society, making the scientific knowledge available, accessible, and reusable for everyone, and opening the processes of knowledge creation, evaluation, and communication to all actors, even beyond the academic society. And then this is another graphical representation of the pillars of what they call the pillars of open science, what the open scientific knowledge, and what on that we have the scientific publications, research data, open educational resource, open source software, open hardware, the infrastructures, the physical and the virtual infrastructures for open science, the engagement of societal actors, and we have citizen and participatory science, scientific volunteering, crowdsourcing, and crowdfunding of science, and then a fourth dimension that is related with open dialogue with other knowledge systems, where it is included the local communities, marginalized scholars from minorities, and also indigenous people. Usually, and I will also, I need to make this disclaimer, we usually focus on this part of the open scientific knowledge, and I will do also that. But I will also briefly mention today about open citizen science, but we will be focusing today and next week, especially here, and especially on scientific publications, because I know that you will have another sessions with other speaker where you will be focusing specifically on open research data. So today we will talk mainly about these two components and citizen science. But I just want you to make you aware that really open sciences encompasses other aspects. And for instance, this part of the infrastructures, in a way, is also related with open scientific knowledge, because when we talk about open science infrastructures, for instance, we talk about repositories, also journal platforms and things like that are also really important. And finally, UNESCO has also identified the main values and principles for open science. And regarding the values, the value of quality and integrity, it's also at the core of open science is this question of quality and integrity, and I will come back to it also in a couple of minutes. And in fact, despite probably sometimes there are kind of narratives that open science and open access can endanger quality and integrity. In fact, the main one of the main contributions of open science, when performed correctly, is exactly the possibility to increase quality and integrity, because it makes all the research process more transparent, more auditable, more so where you can check what is really happening. And then the second value is the quality benefit. So open science is beneficial to anyone, to everyone, not to specific groups. The question of equity and fairness, and of course to really have quality benefit, we need to address this point of equity and fairness. And finally, the point of diversity and inclusiveness. So again, open science is also a way to address the diversity, the regional and geographical diversity, but also the disciplinary diversity. And there is a tendency of the last decades to try to impose the same model, the same practices, the same publishing practices, the same evaluation practices to all scientific disciplines, from art science to social sciences. And this is really not a good thing, because there is, and it needs to be recognized, there is diversity of needs, practices on different disciplinary areas. And finally, UNESCO also identified principles, and the principle of transparency, scrutiny, critique, and reproducibility. And as you can see, there is a strong relation between this principle and the value of quality and integrity. We can only have quality and integrity in science if really we can have transparency and scrutiny about the results, the data, the publication, etc. And then the quality of opportunities, responsibility, and accountability, the collaboration and inclusion. Again, it's a very at the core of open science. Flexibility, and also the point on sustainability. There are many graphical representation about open science. For instance, this is a tree that represents that there are these different components or aspects or dimensions of open science. For instance, this is one that I also like, that is related with that was created in Maastricht University, where you can see the trees with different branches, so open access, public engagement, fair data, fair software, open educational resources, recognition and rewards, and others. And then I also really like this one, and we start using it probably 10 years ago. It is the open science umbrella, and because really open science is a kind of an umbrella concept that where different concepts and practices and aspects are included. So open access, open data, citizen science. Here it's not represented, but also open educational resources, open source software, and source code. Uh, these are all components and aspects of open science. I will now ask you again to go to Mentimeter, because I would like to know the level of of knowledge or comfort you have on this on the different aspects and dimensions of open science. So again, please go to menti.com and use this code 4542. Let me just move. I think I need to move the slides. Yes. Okay. I move the slides. I think you can reply now. So go to menti.com. Use insert again. Or if you're already there, you don't need to. You just need to reply. For the ones that have not replied to the first question, then you'll need to open the Mentimeter again. But the ones that already replied to the first one can reply now. So just see if there is any question here. Let's see it. Okay. So the scale is 1, you have low knowledge, to 5, you have strong knowledge. Yeah, 3 replied. Let's wait. I would really like to have more answers here also. At least the same number of the first question. Hopefully more. Still missing 2 persons that have replied to the first one. Okay, 5. 1 more to go. Okay, while we wait, so So I must admit that I'm a little bit surprised because the difference between the different components is not very so high. Usually, these two open access to publication and research data will have stronger uh, uh, knowledge level, so significantly strong knowledge level to open educational resource and or citizen science or open source software. And then in this case, there is a kind of a balance on the different areas and less, except here on research data management and fair data. So it's not a common pattern, but it's interesting. So it's clear that then you will really benefit also from the sessions on specifically that you will have on open data. I will talk very briefly on open data today, but you will have specific sessions on that. So the second question that I will try to address now. So we talk about what is open science, so why open science is a good thing, and what the open science is needed. This is a slide that is from a person, Mark Shields from Science Europe, and there are and the categorizing four main areas or reasons to push for open science. There are scientific reasons, so because paywalls or limitations are an obstacle for the dissemination of the research results within the scientific community and to promote further knowledge creation. There are societal reasons, so also barriers and paywalls hamper the uptake of research outcomes, research results by the society. There is ethical reasons, so because if the research is mainly publicly funded, should remain the results should be also public domain. And there are economic reasons because the current, especially related with publications, the current models are unsustainable and with rising costs, and so there are alternatives to that, and we'll talk about that a little bit. I like to also in a way categorize all these in three points that I really like to emphasize, and this is a slide that I've been presenting also probably on the last 8 or 9 years about this about the reasons for open science. One is that because open science is the best way to promote the progress of research and the generation of new knowledge, and I will come back to it in a minute. Second, it's because open science is the way to make science more efficient, more transparent, more reliable, and more reproducible. And again, I'll also talk a little bit more about that. And finally, because open science is the way to facilitate innovation and maximize this the social and economic impact and the return of the investment that our societies are doing in science, because most of the science, especially here in Europe, the vast majority of research is done with public funds, so with our tax money, with taxpayer money. So it's only reasonable and fair and expectable, and we would expect that the money that our societies, that each of us is contributing with our taxes to research would be the results of that investment should be made also available and contribute to the collective, to the global benefit of society, and not mainly or exclusively to some particular interest. And I'm saying probably I will not be working until that day, but maybe that day will eventually come, where we don't need even to talk about open science, because it will be just science, and science just done right. Because I really believe that open science is just the best way, the right way to to do science, and so eventually we in 10 years we will not have to talk about open science, because it will be the normal science, the day-to-day science. So let me just briefly comment on those points. About the research progress. We have now recently we have the example of COVID, but that was not the first situation where when we had a crisis and we need to generate knowledge and answers and medicines and strategies to fight health risk or other types of risk. One of the things that we collectively have done is to open up all the knowledge that had previously existed about that problem, and also to open up the process of new knowledge creation. And that happened 7 or 8 years ago with the Zika crisis, and again and that happened again now with a pandemic crisis, and I'll talk a little bit more about that. But another aspect also, because it's because opening the research process and opening data and opening publications is also a way to validate and correct results and combating fraud. This is an example. I will not go into the details, but this is an example of something that had a strong impact in the lives of millions of people, because the reaction, the economic theory that underpinned the IMF, the International Monetary Fund, response to the debt crisis in 2009, 2011 was based on a theory or economic result that stated that countries that had more than 90% of debt on the 90% of the GDP would have a slow growth. So the countries, especially in the south of Europe, that in that crisis had more than the 90%, and there are several, they had to suffer a strong austerity measures to try to reduce the debt. But it turns out that it was not a fraud, it was a mistake by the original researcher that was discovered several years ago by a PhD student, because the data that was related with that paper was available. A PhD student looked at it and he discovered that there was a mistake. Not all the cells were included, so some cells were left out, and then the results were not the same. So it was not. It was not true that all the countries that have more than 90% of GDP or that of 90% of the GDP had slowed down their growth. So that was a mistake that was made, but it was made clear because the data was open. Because otherwise, probably we will still think the same thing today. And then the most recent case is COVID, and we know that. There are several things that we have witnessed. So during the COVID pandemic, and in fact, the reaction that it was only possible to have two things that we probably should remember about the COVID pandemic. One is that related with the vaccines and the great response that overall we had about to the pandemic. One is that really open science has accelerated the generation of knowledge and solutions from sharing the genetic code of the sequencing of the virus to data related to health condition of patients, to medicines, etc. So we have shared openly data. We have promoted open access to publications. There was a very strong rise of publication of preprints. The related peer review. There was very fast peer review and open peer review, and also start to have overlay publishing. I will come back to this overlay publishing and peer review and preprints on the next more deeply on the next session, so in next week. But these are all open science practices that really have increased a lot during the pandemic. This is one thing. And the other thing, it's not related with open science, but we could also only have vaccines because there was some fundamental research, not applied research, that was made several years ago. So it is really important that there is not only applied science, not only applied research, but fundamental research, because it was that fundamental research made several years ago, I think more than a decade ago, that allowed us to have the mRNA vaccines, because that knowledge and that technology was already developed without any practical immediate practical application at the time of the research. And so we have we have learned some lessons from COVID, that it is fundamental to have timely and free access to scientific knowledge in the form of data, publications, and information. That is important. The importance of collaboration and sharing of scientific collaboration and sharing at all levels. The importance also of science and society dialogue, and the human right to really enjoy the benefits of scientific progress. I think we have learned this during the pandemic. It could be a sad irony that we lost, that we start forgetting about it on the coming years. So I think I will move on this Mentimeter, because we are not having a lot of participation. So I will move on to the third question about open science, and the more practical one. So the how open science how. I think again we should take in consideration what is open science to understand how open science should be performed. So there are kind of two main dimensions of open science. So open science is openness in the results, and open access to publication, open access to data are fundamental building blocks of open science, and without them there is no open science at all. But even if they are fundamental building blocks and indispensable building blocks, openness on the results is not sufficient, or is not fully open science, because there should be also openness on the process, on the doing of the research, on the doing of science. So we are talking also about openness on the workflows, on the tools, and on the infrastructures that are used for doing research. And so on that first part, there is, as I said, the main pillar of open science is open access to publications and research data. But really, we need openness in all the research cycle. So from all the processes, from the conceptualization of research, the data gathering, the analysis, publication, and review and evaluation, we need open science has also a role in each of these steps, and there can be open science practices in all of these steps. This is a representation. I will then arrange to share these slides. I'll probably will put it as a Google file where you can download it. I will do that probably on the next session. So I will share this one. So this was developed by Bianca Kramer and Jeremy Bosman. Where you can, this is an illustration. It was already made some years ago. This is also, I want to point this out. Some of the tools that are included on this slide, that were included on this slide, because this slide was from 2017 or 18, so already 6 or 7 years ago. Some of the tools are already non-existent, or there are other tools that are available. But I just want to use this to illustrate that we can have there are tools and practices on each step of the process. So from opening and sharing proposals, so research proposals, to start sharing reference libraries using there are several also software, but one like Zotero, using project registrations. I will come back to that in a couple of minutes. To sharing initial data that is collected or generated, sharing the code that is used during the research, sharing notebooks. I'll talk a little bit about that in some minutes. Sharing protocols, sharing using open authoring tools to start writing the papers, and using actionable formats. Then when the paper is ready, is written, sharing the preprints in a preprint server. Again, I'll talk a little bit more today and next week. Using open peer review, publishing the results in open access. Talk a little bit later. Using open licenses like the Creative Commons licensing, sharing the posters and presentations at conferences, and communicating through social media and Twitter. As you can see, there are lots of practices and tools that can be used throughout all the research process, since from the initial research design or proposal to the final communication of results. Sorry. And as you can see here, so you have these tools and processes at different steps of the research process. So from the conceptualization to the search and collecting of information, to the analysis, and the writing, the publication, the outreach, and finally the assessment, also using alternative evaluation, and we'll talk about that next week. And this is another representation. It's a more recent representation of these possible workflows. And I must point out that not all of the tools that are included here are open. So some of them are not open tools, and probably I will not. There will be. It will be better to use alternative ones that are open to the ones that are not open here. We will not go into the details here. So talking of also trying to summarize a little bit all this and focusing on the areas that we'll talk less today. Some practices and tools that may be useful. One is what we call pre-registration. So when you are starting a research project, you start by so you start to document your research plan and submit it to registration to a registry. There's some registry, and it separates what is called hypothesis generating research from hypothesis testing research. And there are several benefits, and one of them, probably you will talk about that on the other sessions about data management plan, about the research data and data management. But there is really a value when you need to write down what you are planning to do. You are obliging yourself to think about it and to critically think about what you are planning. So it is really useful to do it at the early stage, because you can eventually, when you do it, you can probably already identify some possible problems or some doubts or some issues that need to be clarified. While if you just starting doing things without having a proper plan, then you might at the middle of the process you might encounter some problems. So the fact that you have do this prior registration and you register on the registry is really important to kind of consolidate your research plan. And it also it has an advantage, because when you do that, then if there are other people that are working on similar areas, they can identify that, and they can also reach out to you, and there's also an opportunity for collaboration with people that are probably planning to do similar research. Then a second practice that is also being used in some areas is what is called register reports. So it's doing the peer review before the results are known. So it's a publication format where the important part is the research question. So and the quality of the methodology to conduct to reply to that research question. So what is evaluated is if this research question, so this is that you are wanting to evaluate, is really useful, is really relevant. It's not useful, it's really relevant. And then if the methodology that you are using is appropriate. And the peer review, there is peer review on top of that, so your peers will evaluate that. And then there are already more than 300 journals that are publishing registered reports. So you already publish what you are doing, what you are planning to do, or what you are doing independently of the results. And then you can publish the results at the end. But the main point here is that the importance is not or the focus is not on the results; it's on the research question and on the methodology. A third practice and where there are also tools. I have on the slides you can find a lot more information on these links, because we don't have time. I don't have time to go deeper on these aspects here. Then another fourth area is open protocols. So it's protocols that document and communicate the research methods unambiguously. So with very detailed, step by step, all the order of the steps, the tools that are using in each step, the equipments, the reagents if there are if there are. So everything is documented very clearly and detailed. So other researchers can easily reproduce the exact procedures. This is again very important in science. Science should be reproducible. If science is not reproducible, it's not really good science, or it's not really science at all. There are some tools and services to do that, and one of them is this protocols.io that I put the link here. And the fourth practice and tools that I want to highlight is the use of open lab notebooks. So making or electronic lab notebooks, but in the question they can be open or not, the electronic lab notebooks, but usually if you are using electronic lab notebooks, it's because you also want to share it with others. And so it's making the record of the research publicly recorded, publicly available day by day. And it can also be useful in some, for instance, in some control environments where there is, for instance, security or biological problems or hazards, or where you cannot, for instance, you cannot move from the control environment to the outside any artifact. Then, if you have an open lab notebook or electronic notebook, you can record your notes in a computer or equipment inside the lab inside the control environment, and then you can use and reuse it outside the lab, and you can reuse it for yourself or your research group, or you can open up to the community in the case of open lab notebooks. And there is also several tools, and there is an example here on the slide. And before going to data, to open access to data and publications, I would like also to spend a couple of minutes on citizen science. Let me just make a short stop to have a little bit of water. Okay, so this is also, as you may remember, it's a component of open science is also the societal engagement, and there are also several definitions of open science. This is a definition also already with 10 years. And saying that citizen science refers to the general public engagement in research, scientific research activities, where citizens actively contribute with their intellectual effort or their surrounding knowledge, or with tools and resources. So it's a very broad definition of open science. Open science has been growing a lot on the last probably on the last 2 decades, and almost around 10 years ago, the European Citizen Science Association, that has many members, had already identified the 10 principles of citizen science but this is a kind of the reference document regarding citizen science, where it identifies the principles that citizen science projects actively involve citizens as in different roles as contributors or in different possible roles as contributors, as collaborators, or even as project leaders. They have a genuine science outcome, so they are really science. It's really science. It's where both professional scientists and citizen scientists have benefits of participating, and there are several benefits for both of them, both for scientists and scientific institutions and citizens. That the participation on the projects by citizens may occur in multiple stages. That citizen science should receive feedback from their participation. That citizen science is a legitimate research approach, like any other, of course, with limitations and biases that also should be considered and controlled. But as other research approaches too, that citizen science results should be made available and publicly available and openly when possible, and that citizen scientists should be acknowledged and on the project results. And so, for instance, regarding authorship, if there are publications resulting from project with participation of citizens, their contributions should be acknowledged on those publications. And citizen science programs should be also evaluated as the other projects for the quality and the impact, both scientific or society or political, and that citizen science projects need to take in consideration legal and ethical issues, like all the others. There are different types or modes of citizen science. The most common one, and where probably the vast majority of citizen science projects are focused, or citizen participation projects are focused, is on data collect, on this middle part, data collection or analysis, mainly on data collection. So where you have citizens collecting using sometimes almost like sensors. So, for instance, where citizens contributed with their own data, or when, for instance, there is citizens that are collecting information about biological diversity, or by using their cell phones and taking photos on specific areas or processes. So there are different ways of doing that. Then when we have participation of citizens, both on the definition of the problem of this research question and the data collection, we call it participatory science. And by the way, the first one, and it is the more common one, so where citizens are mostly data collectors, it's usually called just crowdsourcing. It's really a crowdsourcing way, where we have citizens involved in data collection and analysis. It's kind of also an extension of classical citizen science, where people is involved in analyzing the data and results. For instance, there was several projects, and that there still is several projects where citizens are involved in analyzing images, big volumes of images, and of course, for instance, now maybe this at least some of those projects will not be as useful as they were, because now we can probably apply artificial intelligence to do some of that analysis that was made initially or until recently by humans. And then we have the kind of the extreme citizen science, where citizens are participating in all these moments of the research, from the problem definition to the communication and engagement. And this is what can be called extreme citizen science. This is again another representation of the different roles of citizens in of different shapes of citizen science, or what is called the contributory citizen science, where that was the vast majority of the initial projects, and even now many projects are mainly focused here. Again, so it's the scientist that designs the project. Then there is the methodology. It's defined a methodology where citizens are mostly data gatherers, and the new shape of citizen science. And there is an increasing number of projects that are using this approach of co-creation or participatory approach, where also citizens and citizen organizations help to identify problems, real world problems, the real problems and research questions. Scientists are contributing with designing a research approach and the methodology, and then also the data collection, and then the analysis and the reflection and the conclusions is also shared between professional researchers and citizens. And finally, to end this part on citizen science, just this is a graph about when to use citizen science, or when it is more promising to use citizen science. So it is good. Citizen science is especially appropriate on this top part of this continuum on different aspects. So when there is a clear question, a clear research question, when engagement is important, when there are resources to involve on the project, when we need large scale samples, when the protocol, the research protocol, is not too much complex, and where, for instance, when we are using real world problems or real world issues that probably can generate motivation of the participants, so there can be goodwill to participate and goodwill to participants. These citizen science projects are really very useful and very promising. And on the other end, and of course there is a lot of you may not have all this, but if you have 3 or 4 of these, this could be already a good choice to use a citizen science approach. But of course, if you are more on the bottom of this aspect, so if the research question is vague, if there is no just one-way communication, if there are low resources, if the sample is small, if the protocol is complex, or if there are really no clear reasons for people to participate, of course, citizen science is certainly not a good option. So again, you need we need to really critical think about this. Okay, I move on to the second part of today. I will start to briefly talk about open data and open access, but let me just check. Let me just stop here for a minute also for me and see. I don't know if there are any questions already that someone wants to raise. You can use eventually now. You can use the chat. I'm seeing it, and or you can just open your microphone. Something here on the chat. Let me look. I cannot see your presentation. I suppose, can anyone just reassure me that you are seeing my presentation? Yes? Okay, thank you. Thank you, just to be sure, because if it was a general problem, then that would be really worried. Okay. So let's, if not, let's come back, and then we will certainly have time at the end for some questions and debate. So as I already told, the main pillar of open science is open access to publications and research data. You will have specific sessions on research data, so I will not go deep on that today, but just a couple of minutes or 5 minutes at the most, just to give a very broad overview, because I think it's also useful on this context of introduction to open science, and then you will have specific sessions on research data, and where you will certainly go deeper on this. So also starting by a definition of research data, what is research data, and we can say that research data is any information that is collected, observed, generated, or created to validate research findings. So in short, is anything that researchers can produce or review or work during the research process. Then another concept that is important is open data. Open data is any data is data that anyone can access, use, and share. So, and this is important. Especially, there are two aspects for open data that are fundamental and indispensable. So, open data should be usable, and to be usable, it has to be made available in a common, machine readable format. So, also on an open, ideally on an open format that is not dependent of a specific software. So it's and it can be also it can be understandable and usable by machines. And then the second aspect, and it's also related with the first one, is that open data must be licensed to make clear the conditions where it can be reused, and so then the licenses should be as more open as possible. So for research data, usually it is recommended to use a CC0, so Creative Commons 0. So it's a license where you can do everything with the data, even without recognizing the source of the origin. So you don't, CC0 means that you can do with the data whatever you want. You don't have any obligations regarding the use of data. Another common and or recommended license is CC BY, so Creative Commons BY, where you also can do everything that you want with the data, but you need to recognize the authorship or the origin of that data. So for data, really the common is the recommended is CC0 or CC BY. And this is a representation that I think it's simple, but it's nice, and I think in a way it encompasses it represents well this this world of data. So we have this big ellipse is the everything, all the data, and then you have two, three subsets that partially overlap each other. So you have the subset of open data. Don't take into consideration the size of the balls, because they probably would be different from that. The important part here is not the size, is the overlapping of them. So we have one part that is open data. Again, is data that has a license and is open format, and then we have another circle that is the data that is managed, and you can see that open data can be managed or not managed. So because if you just have a license and an open format, this is not completely managed data, and I will explain a little bit. I'll talk a little bit more about that in a minute. And then you have another circle that is the fair data, and the fair data. So all the fair data must be managed data, and and part of the fair data can be also open, but not all the fair data can be needs to be open. So and again, this is don't worry about the size and even the percentage of overlapping. So probably fair data, the overlapping of open data and fair data probably should be bigger. So the percentage of fair data that is open data is big. So here it seems to be small, but usually it is big. But the truth is that the main point is that all the fair data must be managed, but not all needs to be open, and not all the open data is managed data. But again, you will probably will go deep on this on the sessions with the other speaker. So and what is managed data is data that has go through this process of research data management that has several steps or several moments, from the creation to the processing to the analysis and the preservation and the sharing and reusing of data. This is a very well known representation of research data management. And then for the research data, we talk about fair data, data that is findable, accessible, interoperable, and reusable. Again, you will certainly go deep on this on the other sessions. But I want also to highlight here one principle regarding the data, and this is also why not all the fair data needs to be open, because regarding data, the principle is as open as possible, as closed as necessary. So contrary to research publications that we will talk afterwards, for publications, there is no good reason why why publications should not be open. So all publications should be open, period. And if you don't agree with this, we will have the opportunity probably to talk and to discuss that point. But in my opinion, and the opinion of many people, all publications should be open with no exception. Regarding research data, there should be the default option should be openness, but there are good reasons why several research data cannot be and several data sets cannot be made open, for security reasons, for data for personal privacy reasons, for different reasons. So some data cannot be made open, or this cannot be made open initially, or cannot be open at all, not initially, not never. So the principle regarding data is as open as possible, as closed as necessary. That's an important distinctions that we need to make. And this idea that not all the fair data needs to be open, while of course it should be every time that it's possible, it should be made open, and open should be the default. The fair data is based on the fair data principles. I will not go on the details here. Again, you will have sessions on this. But the FAIR principles is really about the quality of data, and especially the quality of the metadata. So the quality of the quality of the management of the data that produces good metadata, good representations of the data with persistent identifier that allows to find, locate, and reuse the data set, the data sets regarding the use of also good vocabularies, rich metadata, licenses, technical protocols, and approaches that facilitate interoperability. So that's mainly about the main thing about the fair data. Okay, so regarding open access, so I will switch now to the final section of the talk today regarding open access to publications. When we talk about open access literature, we say that the open access literature is free from it's gratis, so there is no economic barrier, so no cost barrier, also no need for registration, etc. And also it's there is no restriction, or the minimal level of restrictions associated with copyright and licensing. So with no or few limitations on reuse. So the idea is that the literature can be used and reused by others. There are, and those were the initial routes to open access. By the way, open access as a practice is very old. So from already even before the internet, there was kind of open access practices where, for instance, physicists shared preprint versions of the papers by mail, not email, by really sending papers, letters to each other with their papers. But as we know, open access now is, of course, it was only made possible because of the internet, and so it started as the way that we know it, probably on the 90s. But the concept was really only formulated and explained already on the 21st century in a meeting that occurred in Budapest in 2001 that has resulted on a declaration, the Declaration of Budapest on Open Access, the Budapest Open Access Initiative, and that was then made publicly available on the beginning of 2002. And on that declaration of Budapest, they have already identified two ways for open access. One is called gold open access. Is open access provided by the publisher or by the journal editor. So when it is published, the article is immediately made available on the publisher website. Currently, it was not the case at the beginning, but currently there are probably around 1/3 of journals that are charging APCs, article processing charges. So if you want to publish open access, you need to pay an APC. We'll talk, and probably we have the opportunity also to discuss this in the end of this session. But let me already point out, and I will come back to this, that around 2/3 of the journals that are published in the world, the open access journals that are published in the world, do not charge APCs. So even if many people now, it is really a big mistake that many people, when they think about open access, they think about publishing in paying an APC. This is not true. So because there is two ways of open access: gold open access and green open access. And even for the gold open access, so for the open access on the journal side, it's not true that all the journals charge APCs. In fact, the majority of journals do not charge APCs. And and the other definition, or the other route that was identified in Budapest 22 years ago, was what is called the green route, is by self-archiving. So regardless, independently of if the paper is published in a subscription journal or in an open access journal, so the author or someone in representation of the author uploads the final the article into a repository. It was not also the case 22 years ago, where open access was immediate. In many cases now, if you publish on a subscription journal, then you will and you want to put your paper on a repository, you can do it, but it will open access. The publisher will not allow for immediate open access. So there will be an embargo period, a time during when the paper cannot be made openly available, and then after that time, usually 6-12 months, and in some cases even more than 12 months, it is the paper can be made openly available. When we discuss open access, I think it is important to have clear ideas and the concepts being made clear. So one aspect is having clear ideas about the versions. And we usually talk about two main versions, what we call preprint and postprint. Preprints are versions that have not been peer reviewed yet, so there are no validation by peers. So it's usually a preprint is also the version that you submit to a journal, that researchers submit to a journal. But there are preprints that are never submitted to journal. They are created as preprint and they will remain as preprint. So they have no peer review. They have no validation by peers. And then we have other versions that we call postprint. So it's postprints are any version after peer review and acceptance for it's the peer review or accepted version. And postprints can have two different versions, and both are postprints. One, it's called the author accepted manuscript. So usually when an author submits a paper to a journal, it goes through a review. The reviewers may do several recommendations to change this and that, to include that or to cut that, and then there is one or several rounds of revisions, and then finally there is a version that is accepted. Okay, this version is okay, and it will be published. And there is the version that is that version that before the formatting, the typesetting, and the logos, etc., from the journal, from the content part, it's completely equal to the published version, but it has no formatting. But the content, so the text, the tables, etc., so all the content is completely equal to the published version, but there is no formatting, and that's so we call it, it's a postprint, and we call it author accepted manuscript. The other version is the published version, that is also known as version of record. I don't like very much this. I think this version of record is a kind of old-fashioned concept, but we might discuss that. So the published version is the author accepted manuscript regarding content, plus all the formatting, the typesetting, the logos and things like that. So, but both the author accepted manuscript and published version is a postprint, and this is important because many open access policies that I will talk in a couple of minutes, what they require is that the postprint is made available. Both it's not many policies do not require that the published version is made available. They require that the postprint, either the author accepted manuscript when the published version is not possible. The author accepted manuscript is an accepted version to be made openly available, and with that you would comply with your further publish requirements. So this is another representation of this version. So the preprint is the version before peer review. Then there could be several cycles of review and revision, and then the referred the postprint as the author accepted manuscript, and then after copy editing and typesetting, there is the published version. But again, both these two are postprints, and both these two are ways to comply with open access mandates. The other format that I like to highlight here, I already talked about it 1 hour ago, or roughly, about register reports. So it's another form of publication where you can where the peer review occurs on the first stage of the design of the study, where you identify your research question and your methodology, and then after you collect and analyze the data, then you write your report and you publish your report. And as I said, roughly currently more than 300 journals already are using registered reports. The second, another aspect regarding basic concepts that I think it's important to make clear is the type of publication of journals. So we have the traditional subscription journals, so where content is not open access, where you need to have a subscription to be able to access to the content of those journals. We have the hybrid journals, so they are subscription journals, but they publish open access articles. So if you pay an APC, if you pay an article processing charge, your individual article is made available on those journals. But so they have articles that are only available to subscribers, and journals that are available, and articles that are made that are openly available because the author has paid an APC. And then we have the real open access publications of journals that are the open access journals and the publishing platforms. So regarding open access journals, some important characteristics. Again, they are gratis. There are no charges for readers. Authors retain copyright, so when you publish in an open access journal, you can do whatever you want even with the published version. So the reuse is permitted, and usually the license associated with open access journals is Creative Commons by CC BY. So the places where you only need to recognize the authorship. And then you have various business models, but I will just kind of categorize in two big groups. One is APC, so journals that charge an article processing charge. So if you want to publish on that journal, you need to pay an article processing charge. So currently, and as you probably know, the average APC is around 2,000 euros per journal, but there are journals that charge less, more, 500, or journals that will charge much more. Like for instance, the Nature group journals have made an agreement with Max Planck a couple of years ago with APCs of around 9,000 euros per article. And then there is, and if you go to the directory of open access journals, you will see that it's around 1/3 of open access journals charge APCs, and then you have around 2/3 of journals that do not charge APCs. So they are free to read and free to publish, so gratis to read and gratis to publish. They are usually part of university prices or society or attached with scholarly society, so that support the costs of publishing. And all this is now known as diamond away. So to distinguish, so usually it's not completely correct. So, but on current days, we when you talk about gold open access, you talk about journals that are in use of APCs, and when you talk about journals that don't use APCs, we talk about diamond open access. But in fact, these are also according to Budapest, this would also be gold open access. But we need to have, there was probably the need to make a distinction between gold, meaning charging money for publishing, and diamond, meaning not charging money for publishing. And then we also have what we are called publishing platforms that are more recent, created in the last 5 or 6 years by several, especially by funders, not only, but mainly by funders, by Wellcome Trust, Bill and Melinda Gates, and then also the European Commission, where you publish, you can publish the preprints and the revised version. Usually they use open peer review. They may contain publication and other results. And this is, for instance, the example of Open Research Europe. This is a platform that was created by the European Commission. And I will go also deep on this on these new models on our next session. And then finally, I think this is also a concept that is more familiar to you, the concept of open access repository. So this is a platform that hosts research outputs and provide open access and permanent access to research results, and allow people to download, use, and those results. There are different types of repository, institutional repositories. So usually, I don't know if any all of the universities on the Alliance, if you have your own institutional repositories, at least the two ones that I know better, I know that they have both Bragança and La Laguna. They have their institutional repository, but then we also have disciplinary or subject repositories, so repositories that are not attached to a university, but are serving a research community of a certain area or about a certain subject. They are the preprint repository that are usually more known as preprint servers. Again, I will talk about them with some examples. next week, and then we have what we call the catch-all repositories, and probably the most known one is Zenodo, the repository that is hosted in CERN, and it was also created in the context of the OpenAI project, where you can vary that from research data, software, publication. So you have any type of of content from any discipline. And I don't want to also that we focus too much on this, but initially we have the kind of the two colors of open access, green and gold. So green, author provided open access; gold, publisher provided open access. But probably with all the evolution that we had on the last 20 years, now we are using, or some people are using a more nuanced version with more colors, especially, and I think here the really important one that I think it will stay because it's really being used now is the diamond open access that is really a category that is being used. And finally, to this part of the definitions and concepts, we also need to talk briefly about policies. So on the last 20 years, apart from the creation of open access repositories, creation of open access journals, there is also a lot of open access policies that have been established at institutions. So many institutions, many universities have their own open access or open science policies. And I know I know, for instance, the Polytechnic Institute of Bregenz has an open access policy, but also from research founders. So there are lots of research founders that have open access policies and requirements, and also we have policies at the national level and policies at the European level. So even outside of Europe, for instance, there are even many of countries that have even open access laws that define the requirements of open access. I just want to highlight in this context this model is I think it's not the updated one, this document here, but the requirements and the content of the article it remains updated. So these are still the requirements. So in Horizon Europe, following already policies from Horizon 2020 and even FP7, there are open access requirements that are identified on the Article 17 of the grant agreement. So if you have an an Horizon Europe project on your grant agreement, if you go and read the Article 17, you will see these requirements. So, and what are the requirements? So you need to regardless where or when you publish on an open access journal or in a subscription journal or in a hybrid or a hybrid journal, you need to deposit at least the author accepted manuscript. So it's what they said is the final peer-reviewed manuscript accepted for publication. You should deposit at the time of publication. So when it is published on the journal, you need to at that moment you need to deposit a copy of that article, at least the author accepted manuscript in a repository, and the open access should be immediate, so with no embargo. So it's a difference regarding the previous policy, because on the previous policy on Horizon 2020, embargoes of 6 to 12 months were allowed. Now they are not allowed. So open access should be immediate, and should be attached with a Creative Commons license that should be CC BY, so Creative Commons license for articles, or CC BY other versions of that license, CC BY non-commercial, or CC BY non-derivative for MOOCs. And then also one important difference from this policy to the previous one is that now if you pay APC on a full open access journal, that could be an eligible cost, so you can charge that cost to the budget of your project. But you cannot charge APCs if you are publishing on hybrid journal. So if you are publishing in an hybrid journal, you can publish in an hybrid journal, and then you need to deposit anyway the publication on a repository, but you cannot claim the cost of the APC to the project, because it will not be funded. Regarding policies, I also just want to highlight what happened in the last 5 to 6 years with the creation of planners that had aimed that from 2021 onwards, all the publications resulting from the 11 funders that have created planners should be available in open access immediately. There are lots of organizations that it was initially 11, now there are much more, and they also have identified for the people that still need or want to publish in traditional journals, so no open access journal, what they call the rights retention strategy. So where when you publish on a journal, you make sure that at least you have the right to deposit your author accepted manuscript into a repository with a CC BY license with no embargo. So they are producing also some templates of letters that you can use to when you are applying or submitting a publication to one of those journals, that you can inform that you are being funded by one of the funders of planners, and so when you have the obligation to make your author accepted manuscript immediately available on publication, and so you inform the journal immediately about that. So and to conclude, and to have at least 10 to 15 minutes for questions and comments, some practical aspects of how to publish in the area of open access. There are different possibilities, and these are not completely alternative. So you may use, and maybe it's a good idea that you use more than one of these possibilities. Eventually, even the three of them. In some cases, it's you may use the three of them, but at least you should use at least one of them, and you may combine the use of 2 or 3 of them. One is publishing preprints, so I will not talk a lot about it today, because we will spend some time next week talking about preprints and the advantages and problems of preprints. Then publish your article in an open access journal, both on a journal that charges APCs if you have funding to do that, or in a journal that does not charge APCs, and there are many journals that do not charge APC, and archive your publications in a repository. And again, this could be done every time, regardless of the other steps. So regarding journals, and there is, so I know there's a worry, especially regarding of predatory journals and predatory publishers, you should analyze. You need to judge and analyze the quality of journals, and also analyze the policy of the journals and the cost of publishing, especially the publishing costs, the APCs, and also, for instance, if you are publishing on a traditional journal or on a non-open access journal, then you need to check the conditions for self-archive. So, have you the right to deposit your author-accepted manuscript in a repository? Is there any embargo period attached to it, etc.? So this is something that authors need to be aware and there is for the part of the quality and reliability of journals. There is really a very useful a tool. It's almost a kind of a checklist that you should think about or go through before selecting to publish on journal A or B. On this website, the ThinkCheck Submit that probably many of you already know. And finally, you for regarding repositories, probably all of you already have a repository in your institution, so the immediate choice should be deposit on your institutional repository, but if that's not available, if your institution does not have a institutional repository, then a disciplinary or subject repository can be used, or a catch-all repository as another can be used. I just put this table here also on the right. I don't want to also to go into details here, but I just want to stress that putting papers on academia or do a research kit is not doing open access. It's not the same thing as open access for several reasons, because they are commercial platforms, because you don't really know, you have no guarantee that they will be around in 5 or 10 years time. In principle, your institutional repository, your institutional will remain, and so there is they are not recognized as repository, for instance, as for founders, for the European Commission. So if you want to comply with the European Commission requirements, you need to put it in a repository, not in academia. You do. And just to finish, let me go here. Try to where's the Mentimeter now? Maybe I close it. No, I didn't close it. Okay. I would like just to ask, and then I will stop sharing my screen and be open for conversation or for questions. I'd like to ask you what you think are the main problems or obstacles to publish in open access for yourself or at your institution. So it's the same Mentimeter. Again, it's 452-4216 Menti.com, or use the QR code to do that. Okay, everyone replies, so not enough money to APCs. And while you are replying, if you want, you can already open your microphone and your camera and make any comment or questions regarding, because I was speaking for almost 2 hours.
Okay, if nobody wants to put any question, any comment, I think we can finish this session. I apologize for Ernesto Pereira, who had to left the session. And well, I thank you for your attending this session. Thank you, Eloy, for your very clear and very for sharing for us your expertise. Well, I hope that we can meet again in next session, but I think it's next week. Sorry,
I think it's Tuesday.
it's on Monday. On Monday.
No, Monday it's not with me.
Oh no,
yes. You have a session regarding research data. My session, I think, is on on Tuesday.
Okay. Yes.
Yeah, at the same time.
Okay.
Okay.
Well.
So. Okay. Bye.
See you again.
Enjoy your weekend and see you next week.
Yeah. Bye.
Okay. Bye.
Bye. Thank you, everyone. Thanks. Very interesting.